Well, he said, "Can I have your attention, please?" I was like, "No!" I was answering his question. He obviously didn't hear me. All right, 4.1 is equivalent fractions. So we're starting a new section. Thank you. All right, equivalent fractions. We're going to talk about, first of all, reducing fractions to simplest form. Okay, the key being their simplest form. Now, a fraction, simplest form means this. First of all, another way I will express it is lowest terms. Okay, that's another way that we'll say simplest form. Simplest form occurs when a fraction's numerator and denominator have no common factors. Okay? When a fraction is in lowest terms or simplest form, it means that the numerator, the top number, and the denominator, the bottom number, have no common factors. Okay? For example, if I had the fraction 5 over 12, okay? First of all, this is the numerator, and this is the denominator. Okay, it's very important that you know the difference between those two. Okay, but as we look at 5 and 12, okay, 5 and 12, well, 5 is already prime. If I prime factor 12, 2, 6, 2, 3, okay, there's no numbers in common. So that means that that is truly in simplest form. Okay? Now, you don't have to do the prime factorization part. Okay? I'm just showing you that's how you do it. If you don't know if a number is in lowest terms or simplest form, you can always prime factor both the top and bottom numbers and see if they have any common prime factors. If they do, then you can reduce it. If they don't, then you can't reduce it. Okay? So let's look at one that we can reduce. Let's look at this one, 10 over 12. Okay, 10 over 12. Now, obviously, they're both even. 10 is even, 12 is even. So we automatically know what number will go into them. 2, okay? So 2 will go into both the numbers. Now, a lot of the times, 2 is not the greatest common factor. What we're trying to find when we're reducing fractions is to find the greatest common factor between the numerator and the denominator. Now, sometimes you can't see that right off. Okay, it's not a problem. You can always use the smaller numbers. Okay, in this case, 2 is the only number that will go into it. So that is our greatest common factor between 10 and 12. So I'm going to reduce it by 2. Now, when we're making equivalent fractions, okay, for example, if I have a pizza and it's divided into 8 parts, 8 slices, okay, well, if I take each one of those 8 slices and cut it in half, and make 16 slices? Did I gain any more pizza? No, I still have the same size pizza. They're just smaller portions. Okay? So that's what equivalent fractions are. Okay? If I take a large pizza and instead of cutting it in 8 slices, I cut it in 4 slices. Do I have any more pizza than when I cut it into 8 slices? No. It's the same pizza. Okay? So that's what equivalent fractions are. Equivalent fractions are making the same fraction. Here's our pizza, 10/12. Okay? Well, I want to reduce that down. To reduce it down, you have to divide. To reduce, you must divide the numerator and denominator by the same common factor. Okay? So if I take 10/12, I'm going to slide it over here just to give me more room to write. And I reduce it. Okay? I'm going to divide by 2/2. Okay? So I'm dividing 2/2, which if you will look at it, that equals 1. 2/2 equals 1. So as long as I divide a fraction by another fraction that's equal to 1, you're going to come up with the same fraction. Now, what I can't do here is this. I can't take and divide, I'm going to divide 10 by 5, and I'm going to divide 12 by 4. Okay? No, that is not an equivalent fraction. That's a wrong answer. Okay? So you have to have the same number dividing to the top and to the bottom. So, when I divide 2 into 10, that gives me 5. When I divide 2 into 12, that gives me 6. Okay? 5/6. Is that in lowest terms? Well, we just said up here, well, that was 5/12, not 5/6. We said a while ago, well, 5 is prime. 6 is 2 times 3. So 5 and 2 times 3, is there any common prime factor? No. So it is. It's in simplest form or lowest terms. That would be your answer. Now, I believe the directions are saying write 2 equivalent fractions. Okay? So, this is the first equivalent fraction. Okay? We got the first equivalent fraction by reducing. Okay? We're going to get the second one by increasing. In other words, we're going to cut that pizza up, and we're going to cut all the 8 slices in half. And we're going to get 16 slices. Okay? So, here's what we're going to do. We're going to take 10/12, and now we're going to increase it. Okay? To increase it, we multiply the numerator and denominator by 2. All right? You're going to multiply the top and bottom numbers of the fraction by 2. Now, it is purely coincidental that we divided by 2/2, and now we're going to multiply by 2/2. Okay? To increase the fraction, you're always going to multiply by 2/2. Why are we doing that? Anybody know why we're multiplying by 2/2? Why everybody is going to multiply by 2/2? Anybody know? What do you think, Celine? No, had nothing to do with that. Because we're going to take, in a minute, we're going to take 3/4 and multiply it by 2/2. And 2 doesn't go into 3. Okay? Let me tell you why we're doing it. There's not really, it's really not a, the reason we're doing that is because I want everybody to have the same answer. Okay? Understand, let me show you, take 10 over 12 and multiply it by 2 over 2. That would be 20, and that would be 24. What I'm saying is this. I can take 10 over 12, and if I was Tristan, I might want to multiply it by 1,000,000 over 1,000,000. Okay? And I could do that, and I would still have an equivalent fraction. If I was Joshua, Joshua might want to multiply it by 5 over 5, which is an acceptable answer. Okay? So instead of us coming in and having 15 different answers on Monday, everybody will have the same answer. The reducing of it, there's only one option there. The multiplication of it, there's many options. So I want everybody, when you increase the fraction, we want to multiply it by 2 over 2 every single time when you want to increase it. Okay? So let me restate it. You have two equivalent fractions that you're trying to find. One of them you're going to reduce to simplest form. Okay? Everybody will have the same answer there because there's only one way to reduce every single fraction. Okay? Well, not one way. I guess there is only one answer for every reduced fraction because there's several different ways you could do it, and I'll show you here in a second what I'm talking about. Okay? But on the increase of the equivalent fraction, everybody needs to multiply by 2 over 2 every time. Okay? So let's look at another example. 30 over 40. I want to do 30 over 40 because this is what I want to explain what I said when I said it can be done different ways. Okay? 30 over 40. Here's what most of you will see automatically. It's even. So people will start dividing by 2. Okay? You can do that. All right? But personally, I want to try to do the least amount of work as possible. And I know by your papers, you want to try to do the same thing. Okay? Unfortunately for you, you try to do it when it's not right to do it. Okay? So, the least amount of work is if I find the greatest common factor of 30 and 40. Okay? Well, the greatest common factor of 30 and 40 is 10. Okay? And so I'm going to divide 10 into 30 and get 3. I'm going to divide 10 into 40 and get 4. So my reduced fraction is 3 over 4. Okay? Now, let me show you the other way you could have done this. The other way you could have done this is take 30 over 40. You see that it's even, so you just start dividing by 2. 2 into that goes 15 times. 2 into 40 goes 20 times. But the problem is you can't stop there. Okay? Because 5 goes into both those numbers. So you would have to divide then again by 5. 5 goes into 15 3 times, 5 into 20 4 times. So you still get 3/4, okay? But the difference is you got to do more work and you have better opportunity to make mistakes. Okay? So I don't care which way you do it. I would prefer you to do it with the greatest common factor. Okay? But sometimes you can't see that there's a larger number in play. Okay? And so you just have to deal with that. Now, we have to find the second fraction. So this is the first one. That's the first fraction. The second fraction is to take 30 over 30 over 40, 30 over 40, and multiply it by 2 over 2. 2 over 2. 2 over 2 is 60 and 80. 60 and 80. is the next fraction. So that's your second fraction. So these two together are your answers. So 3/4 and 60 over 80 is your two equivalent fractions that you've made. Okay? And that's how we get to both of them. Now, I want you to do this one on your own. Do number 3, which is 22 over 24. Okay? Do that one on your own. Come up with two equivalent fractions, one by reducing and one by multiplying. All right, Emma, what'd you get?
7 over 9.
Yes. 7 over 9. We divide by 2 over 2. 2 goes into that, and 2 goes into that. Okay? And that's where we get the 7 over 9. Now, it doesn't change if they give you a mixed number. It's still the same thing. If they give you 1 and 22 over 48, okay, still the same thing. We're reducing 22 over 48. Okay? And it's going to reduce by 2 over 2. And so that's 11 over 24. Now, I just take that and bring it down here and do 1 and 11 over 24. Hey. Do I need to get some tape? All right. So 1 and 11/24. That's all you do. Okay? Fairly easy. Now, everybody look at number 18. 18 says the algebra portion. Okay, 18 says 10 over 15 is equal to 2 over blank. Okay, so they've taken the fraction 10/15 and they want you to create an equivalent fraction that they've already sort of done for you. Okay, so how you do it is you say, okay, what did I do to 10 to make it 2? You decreased it, so obviously we divided by 5. So if we divide 5 into 15, you get 3. So in the box goes 3. Okay? All right, now, we still got, about 24 minutes left in class, so I'm going to turn you loose on the homework. You should be able to complete it. 4.1. And we're going 1 through 22. So, now remember, you have test number 1 on Monday. Okay, test number 1 on Monday over chapter 3. So make sure you study for that over the weekend. All right, get started on the homework.